In case you're a pretty good LSS specialist or Lean Six Sigma specialist, you're supposed to be aware about one-way ANOVA. ANOVA, or Analysis of Variance, is required by Lean Six Sigma certification. Let's take a good look at one-way ANOVA. One-way ANOVA means Analysis of Variance. In Lean Six Sigma is a statistical tool used in the analyze phase to determine if there are statistically significant differences between the means of three or more independent means categorical groups. It helps identify root causes by comparing process inputs, which are X, to outputs, which is Y. Common applications: comparing the average weight of products across three different assembly lines or testing the effectiveness of three different machine settings on output yield. One-way ANOVA applies to IT industry as well. Key details for one-way ANOVA. Purpose: compares means of populations, means generalization on two sample t-test. Data type: requires continuous numerical output data Y and categorical input data X. Hypothesis: there are two hypotheses. There are two of them. First of all, null. All group means are equal. And second is alternative. At least one mean is different. Assumptions: data must be normally distributed, independent, and have equal variances. Interpretation: if the p-value is less than the significance level, typically 500ths, you reject the null hypothesis, which is first one, indicating at least one group mean is different. Next steps: if the ANOVA is significant, post hoc tests are used to determine which specific group differ. Let's take a good look at one-way ANOVA example. Example scenario: battery lifetime analysis. The problem: a manufacturer wants to know if there is a significant difference in the average lifetime of three different battery brands. Factor means brand, response, and lifetime. Data sets: for example, three different battery brands, brand A, brand B, brand C, with their average and their means, as you can see. Now let's take a look at analysis and interpretation using professional statistical software. First of all, you need to run ANOVA. Attention please, using tools like Minitab or Sigma Excel, calculate the F statistics and p-value. Second, evaluate p-value. If the p-value is less than 500ths, remember, reject the null hypothesis. Conclusion: if p is less than 500ths, the test concludes that at least one brand's average battery life is significantly different from the others. And last one, post hoc test, or so-called TACI. Perform a TACI test to determine exactly which brands differ. For example, brand C may last significantly longer than brands A and B. This analysis helps the team determining which brand to use to maximize product performance, focusing improvement efforts on the root cause, means the supplier and brand. Remember, at this point, one-way ANOVA is required for Black Belt's Lean Six Sigma certification.